Section 15.7, triple integrals in cylindrical coordinates. Earlier in section 15.3, you learned double integrals in polar coordinates. Here we have a recall for conversion between the polar coordinates and the rectangular coordinates. And here we have formulas. X is r cosine theta, y is r sine theta. For the conversion from rectangular coordinate system to polar coordinate system, we can get r and theta by solving these two equations. The cylindrical coordinate system is a simple expansion to one vertical direction or orthogonal direction. In the system, a point P is an ordered triple r theta z, and r and theta are polar coordinates of the point on the xy plane, and z is the directed distance from the xy plane to the point P. So the corresponding conversion formulas must be given in this way. From cylindrical coordinates to rectangular coordinates, here xy can be gotten exactly the same as in the formula for polar coordinates, and z remained the same. The other directional conversion is also the same. Now r and theta can be obtained as in the polar coordinates, and z is not changed. Okay. Once you try to deal with triple integral, and now then the domain is now separated into these two parts, d and another dimension. In this case, d will be polar region. Then, and that is, for this region, we can use polar coordinates so that eventually the system is cylindrical coordinate system. Okay. Let's try to solve some problems. Plot the point with the cylindrical coordinates and find its rectangular coordinates. Okay, that's part A. Okay, A. And now that is r theta 1, and so that z, okay, in xy direction, r is 2, and here angle is 2 pi over 3, so that in negative x direction, somewhere the angle up to this point, and 2 here, there's rotating in this way, and then in the z direction is going up 1, so that the point will be this one. So this angle is 2 pi over 3, and the radius is 2, and then the height is 1. So in this way, you can visualize the point. And we can change it to rectangular coordinates. Okay, x is r cosine theta, r is 2, and cosine 2 pi over 3. So that is now 2, and there's minus half, so that there's minus 1, and y is 2 sine and theta 2 pi over 3, and that is square root of 3 over 2, so that is square root of 3. Okay, and z is remained, so that the point is, okay, that's -1 and square root of 3, there's xy, z is the same as earlier, so that is rectangular coordinates. Okay. Now find the cylindrical coordinates of the point with rectangular coordinates. Okay, it is given in this way. Then that means x is 3, y is -3, and z is 7. And from this one, we have to find r theta from these two. R is square root of x squared plus y squared. So that is 9 and 9. So 3 square root of 2. And theta is now tangent, arctangent, and here y is -3 and x is 3. Okay. It's -1, which means the angle is minus pi over 4. So we can write here, the point is now, okay, r is 3 square root of 2, and theta is minus pi over 4, and z must be the same, right? That is, yeah, cylindrical coordinates. Okay. Evaluate the integral. Once it is given, then of course you can do this innermost integral easily, because it's z integration and independent of z, so you can get it quite easily. So here given integral is, okay, that one, and we can finish this quite easily. Okay, let's try to do that. So it's a -2 to 2, and there is a minus square root of 4 minus x squared. And that is square root of 4 minus x squared. And this one is x squared plus y squared. And length is 2 minus square root of x squared plus y squared. Quite easily we can do that, right? And dy and dx. Okay, for this one, now we have to solve that problem, this portion, but it's not easy. But we may try to visualize this region. Okay, x is moving from -2 to 2. So pictorially, we have here x is moving from -2 to 2. Okay, and for each x, okay, that is y value. This is a bottom y, this is a top y. So for example, for top y, okay, y is square root of 4 minus x squared. That means y squared equal 4 minus x squared. And that is same as x squared plus y squared equal 4. Right? That means in upper portion is that circle of radius 2, like that. But a bottom portion, bottom y, is, even though you start with bottom y, you will get the same result, which means that bottom is also in a circle like that. So the domain is that one. So that this is integral over this disk, and the given integral can be changed into polar coordinates. So that is, angle is from 0 to 2 pi, and radius is from 0 to 2. Okay, this portion. And that is r squared. And this portion is 2 minus r. And we have to put scaling factor r and dr d theta. Okay, now it is quite simple. Theta independent, so that theta integral can be done by this quantity 2 pi. And the remainder part is from 0 to 2 and r cubed, so that 2r cubed minus r to the 4 and dr. Okay, so it's a 2 pi. And antiderivative is half r to the 4. It's 1 over 4 r to the 4. So along with this one, it becomes half minus 1 over 5 r to the 5. And then evaluation from 0 to 2. Right? Okay. Now for that one, okay, now 2 pi is the constant, and this one, there's 16, so that there's 8 minus, that is 32 over 5. Okay, if you simplify, then you'll get the final answer here. Okay. Okay. Find the volume of the solid that lies within both the cylinder and the sphere. X squared plus y squared plus z squared equal 4. This is a sphere of radius 2, and that is a cylinder, and the cross section is a circle of radius 1. So we can visualize the volume in this way. That is XYZ coordinates. Okay, that is X. And now there is Y. This is Y. And this is Z direction. And the this sphere of radius 2 can be made in this way. So it is a sphere of radius 2. That is 2. And we should make the cylinder. Okay, cylinder is given in this way. It's radius 1, like that. So eventually, the solid is like that here inside this cylinder, so that is a top portion, this is a bottom portion. So we have to get the volume between these two red markers. That is the solid. Okay. For this one, the volume is now integral, 12 integral over E and 1 dV, right? In this case, E can be split into two parts. One is two-dimensional region, and the other one is the orthogonal direction. So that is naturally, we can split this E into this two-dimensional one, disk of radius 1, and then from bottom to top, right? Okay, so that is same as double integral over D. And now we have to find the bottom and top. It's bottom over Z and top over Z. And that is coming from this equation. So that Z will be plus minus square root of 4 minus x squared minus y squared, right? So the bottom is minus square root of 4 minus x squared minus y squared. Top is square root of 4 minus x squared minus y squared, right? and integrate this one, and z direction integration, and after that we'll try to get polar integration, right? Okay, for that one it's constant, so that you can get the inner integral quite easily. That is twice of square root of 4 minus x squared minus y squared. The length is twice of this one, and dA, right? Okay, now we try to get integral over d. D is the disk of radius 1, so whole circulation from 0 to 2 pi, and r is moving from 0 to 1, and 2 square root of, okay, that is 4 minus r squared, and we need scaling factor r, and dr d theta. Okay, theta independent, so this outer integral will give the value 2 pi. Okay, now for this inner integral, this is power is half, so that one is antiderivative. That will be 4 minus r squared, and half plus 1 is 3 over 2, and we have to evaluate that one from 0 to 1. Now we have to fill out this unknown. In order to do that, we differentiate, and then 30 over 2 will come out, and that power half, and that derivative is minus 2r, right? Okay, let's try to simplify this one. There is a minus 3, and there is a half power, and r. Of course, this inside is 4 minus r squared. Compared with this one and that one, and only the difference is here, if we put here minus 3 over 2, then that will become 2 over there, right? So that this unknown coefficients must be minus, okay, no. That is 2 over 3, okay? It must be minus 2 over 3, right? Okay. From this one, now that is 4 pi over 3, the coefficient, and along with this negation, we first evaluate that one along with the 0, then 4 to the 3 over 2, and 1, then it's 3, so that's 3 and 3 over 2, right? And of course this value is, what is the 8? Anyway, this is the final answer, okay? Okay, that's the end of section. Thank you.